face and the rake face of the tool, or the interface between the chip and the tool, can be found with certain formula. So let me write down the formula and then we will go further. But you should, this formula is change in, or the rise in temperature is 0.4 times specific energy, cutting energy, divided by the density times the specific heat capacity. Cutting speed times the chip thickness divided by thermal diffusivity, whole to the power 1/3. This formula is applicable if the width of cut divided by the depth of cut is greater than the 5. And alpha, we studied in our reviews that alpha equals to thermal conductivity divided by the density divided by specific heat. This formula has been derived using this dimensionless group results, and this formula can be found from in your slides, which you should write down in your formula sheet for your test 2, which will be next Thursday. Okay, let's try to apply this formula in our problems. Okay, this is our problem. Estimate the chip tool interface temperature. When the cut on the lathe, the feed is known as the thickness of the chip, and the width is the depth of cut. You remember it's like turning, you remember that one. So if this is the tool, okay, so tool is moving like a feed. Suppose in one revolution, I'm exaggerating. Suppose the tool comes over here in one revolution. So from here to here, this is known as the chip thickness, and the depth of cut is equal to the width. So this rectangular chip which comes out is T0 times B. This is my B. And now let's go back to our question. You have to find out delta T. You need to apply this formula. So I'm going to write down this formula again. And for this formula, you need the density, everything. So let's see. I want to show you the next slide here, which tells me what are the values of these variables. Thermal conductivity is 16.2, specific heat capacity 500, the density 8000, alpha thermal diffusivity is given. Okay, let's check. What is the ratio B over T naught? So B is the depth of cut, which is 2.54. I can write here 2.54 divided by the feed. In turning, the feed is equal to the thickness of the chip, which is 0.38 per revolution millimeter. And this is equal to 6.67. So it is greater than 5. So we can use this formula. So let's plug it in. 0.4 parenthesis specific cutting energy is 1.96. It has been already converted into the Pascal. So 1.96 into 10 to the power 9 divided by the density divided by the specific heat, which is 500, times the speed, which is 1.5, 1.5 times the thickness of the chip, which is 0.38 millimeter. So I can write down 0.38, convert it into meters, divided by alpha, which is 4.05 into 10 to the power negative 6 meters square per second, whole power 1/3. If you do the math, you should get temperature rise chip tool interface is 1020 kelvins. And the T at the room temperature, ambient temperature, I will say the total temperature will be 20 Celsius. So melting point is 1421 Celsius, that is equal to 1694 Kelvin. It's about 80% hot, 80% of melting point, very hot. So have you understood how to apply this formula in our analysis? Yes. In 40 Celsius. What do you get for delta T? If you get, it should be Celsius then. Which is equal to 1313 Kelvin. Because 1 Kelvin equals to Celsius plus 273. So you just add 273 into this number. With that, we have finished this section. Some of the economics review. We can go ahead and understand. I will skip some of the slides to save time because they are just reviews. And then I'm coming to the main topic is the Taylor equation. What is the Taylor equation or tool's life? Because when you are cutting uh, any workpiece, metallic workpiece, so you need to know what is the tool life and how can you find out the cost of manufacturing. So that is my objective. So, but before I go over there, I want to just review some of the things here. Future value is F, present value is P. You can do the single repayment to the bank where you borrow the money to run your company, or you can divide into periodic repayments per month or per year. Like our mortgage, every month we pay to retire the debt we borrow. So this is the formula. Please write down this formula to find out the future value. If you invest, and this is the same formula written in a different way. The question is, amount you borrowed from the bank is $20,000, and the bank says he will it will charge you 9.5% per year, and you pay back the same loan after 4 years, lump sum. You don't have to pay any periodic payments just after 4 years. So how much you have to pay extra? $8,753 you will pay extra. And now the next question is to find out the present value if you know the future value. Suppose you need 250,000 in 16 years to send your child to college. Assume you can make 8% per year. How much should you invest today? Okay, this is the formula. Present value if you know the future value in 16 years. Do you understand that review? Economics review. Have you taken economics class before? You have studied these formulae over there? Econ? Suppose if you have borrowed from the bank the present value and the interest rate I and repay it within n number of years or n equal payments, annuity. So cash goes to your bank. This arrow means you are getting money. This arrow downward means you are subtracting, like y-axis, you remember? Upward is positive. Your bank gains money and then you have to pay annually or equal payments. So these are the formula. Future value, if you are interested in uh, periodic equal amount of payments. Suppose if this is annual payment, then you will keep this n as number of years. But if I ask you a monthly payment, then this would be in months. And you would also replace this interest rate per month. These changes you would do, look at the situation when you are reading the numerical problem. Okay, how much will you pay back? Suppose if you can you solve this question? You borrow this much money for your car, 8% per year, 4 years. How much will you pay back? And how much will you pay back per month? So I would say use this formula first. Future value. And then per month, you will use this formula. Okay, let's see. Number of years are 4, so it will be 48 months. 8% per year means 0.67% per month. So I'm using this formula. You see, if we are using monthly payment, then we have to accordingly change N from years to months, I from per annum to per month. So the total periodic payments for 4 years would be this much. Interest payments is $4,317. Another question states, using the previous example results, should you borrow the money and use your savings to pay for the loan, or buy the car from your savings? You earn 6% rate in your savings bank. Sorry, this one. Okay. So you will solve this problem. 48 months, principal plus interest. Keep on reducing. The principal and interest keep on reducing. So you would not have enough money from your savings over the term of the loan to pay for your, so buy the car with your savings. It's okay. I want to show you the formula here. Yes, please write down this one. Suppose if you have a total cost, which is the material cost plus the labor cost times the number of parts plus the indirect cost per year. Indirect cost includes the taxes plus insurance, and the direct cost includes the material direct cost, CD. Okay, so you can find out the total cost. So manufacturing cost, direct cost includes the material and the labor to produce the number of parts. For example, if you're producing some sort of machines, you need to have a material and the labor to manufacture those machines. So you have to have also pay the machine tool cost, indirect payment, which is 33% roughly the cost. Another formula is, you can write down here, the direct material cost is C sub M, part weight, and the scrap weight. Some scrap value, it depends how much is the rate. Suppose 30%. It should be 30%. The scrap rate. Salvage value is, suppose if you buy the car, is now no more working. Suppose you still have salvage value $300 of the car. You will subtract that from the 100%. One means 100 minus salvage value. It will be like percentage, the scrap value. So let me show you over here. before you are deciding to make the part of the stainless steel, aluminum, the parts would have the same volume, determine the direct material cost. So let's see how will we solve this problem. Since both parts have the same volume, so we will do the calculation on the per volume basis. Assume 30% scrap value rate for steel, 15% scrap rate for aluminum. So density, you can find out the weight from the density because I'm interested in using this formula. Direct material cost. Find the direct material cost using the formula above this one, CM. So let me write down this formula here. Yes, let me write down for you. Okay. The direct material cost for steel. If you understand for steel, you can easily, because you know the part weight, the density is given, and the volume is assumed to be 1. Density equals to mass per unit volume. Suppose volume equals to 1, so the same density multiplied by 1, mass equals to volume, density times volume, and this is density times scrap weight times 1 minus 0.1 plus 0.3 scrap rate 30%. So this is the direct material cost for aluminum, for steel, and for aluminum this is about 515, 511 dollars per feet cube. But I will again say you go home and read these slides again, okay? Then comes the direct labor cost. Labor cost is also the direct cost. And try to understand this, the formula here, where the cost per part, labor cost per part, number of parts produced per year, times the labor rate per hour, times the number of hours in 1 year, and is the number of parts. Sorry, small n is the number of workers. Okay, let's do this question. Suppose you have two factories A and B which have different parameters. I'm going to show you this. Find the direct labor cost in making a specific number of parts per year. So you see, same formula. 3 workers per, suppose per lathe machine there are 3 workers, and the labor cost is $35 per hour, and total hours used on the machine is 2000 per year, and the number of parts are 10 millions. So if you use this formula, so you will get 2.1 cent. 3 times 35 times 2000. $0.021. Do you understand? So you would use factory A because you are saving 3 cents on labor cost on each part. So indirect manufacturing cost, let me show you this for packaging cost, testing, rent, indirect cost. Indirect cost. Okay, the total machining cost. Hourly machine rate, machine cost. C0 initial machine investment. H is hours of use per year. And then we have depreciation, annual allowance of depreciation. This is depreciation because every year it depreciates. Suppose in the beginning is $100,000, the lathe machine, then it comes 90,000 every year, decrease of a few dollars. So tax amount, you are paying taxes, insurance, and average maintenance allowance to repair the machine. And here comes the labor cost, number of operators, labor wages, 1 plus B, burden overhead rate based upon the direct labor. So with that, we have finished this topic of economics review. Now let me go over, when you go home, do the machining part 3. Part 3 is, you will read by yourself. Part 3, machine cutting to life. Yes. For machining module number 4, you will start from slide Taylor's equation. This is the Taylor's, it will tell you how will you calculate the tool life. V is the cutting speed, T is the tool life, N and C are the Taylor constant. Another extended, the same equation can be further extended in 3 variables: cutting speed, tool life, and the feed rate. For high speed steels, this can be written this way. Okay, let's do the derive the Taylor equation. Can you use this formula? Vt. Suppose this is case 1, this is case 2. So let's see, V1 T1 equals to V2 T2. What is N? Can you find out N? This is just simple math. What is V1? 3.1 times 19.95. 3.6 times 12 point. Here we have a tool life in minutes. We have to convert it in seconds, right? Because this is in minutes, this is in meters per second. I will say multiply by 60. In minutes, this is the tool line. In seconds, this will be. Can you do that like this? So what do you guys get? So this is the equation which I was interested in. So I think we have to use surface feet per minute. So let's do this like this. Surface feet per minute times 19.95 power n. Surface feet per minute 3.6 power n. So if you do the math, you get n equals to 0.31. Taylor's tool life can be calculated like this. Yes, another important formula is the surface roughness. So when you cut the workpiece, it it has some marks of roughness very at micron level, micrometer. So there are two types of roughnesses. One is the average, one is the peak to peak. So if you cut the tool like this, and if you see from peak to peak, the roughness is this. So I would say the total roughness is f square of 8r. But if it is the average roughness, this is the rough. So if you take the average line, arithmetic average is f square 18 square root 3r. R is a nose radius. So every tool has a nose radius and arithmetic average. T is the peak to valley, that difference. Okay, we have finished machining slides. I'm gonna share with you the homeworks we have done.